To January 19, 2019, Unit 4, MCQs. The first we have, which of the following unit is equivalent to farad? So we have the formula Q is equals to CV. So if we need the capacitance, because farad is a unit of capacitance, so capacitance will be Q divided by V. So what is the unit of the charge? The unit of the charge is coulomb and the unit of voltage is volts. So it is coulomb divided by volts or CV minus 1. So it matches with option B. The potential difference V is applied across the two identical capacitors in series. So we have one capacitor connected to another capacitor and both are connected in series. Which of the following expression is the total energy stored on the capacitors? So how we'll know the total energy stored by the capacitor? Because when two capacitors are connected in series, the voltage will divide between them. Like if we say it is connected to a supply with a total voltage V, so what will the potential here? It will be V by 2. And what is the potential here? It's also V by 2. And if each capacitor, they are the identical capacitors. So let's say each capacitor is having a capacitance of C. So the formula which relate the energy stored in the capacitor is having different formula, half QV, or energy stored is half CV square, or energy stored is half, because Q is equals to CV is there, or V is equals to Q, so Q square over C. So these are the three formulas. Because they are identical capacitors, so we said that each is having a capacitance of C. They already mentioned. A potential V is applied across them, so potential will become half. So we cannot use this formula because we don't know the charge. Even we can know the charge because like voltage and charge are directly proportional. So if you want to use this formula, the first formula, you can use, but I prefer to use the one which is having one constant. So as you can see here, capacitance is constant. So if I use this formula, E is equals to half CV square. C is constant, so energy stored is directly proportional to V square. Because if the voltage is divided by 2, what will happen? The energy will be divided by 4. Because it vary with the square. So if this voltage divided by 2, voltage become half, energy stored will be quarter. So we need what is the total energy stored in these capacitors? As it is half CV square. So potential for each is like if we write E is equals to half CV square and the voltage become half, so I can say half C V by 2 whole square, or I can simplify this as half CV square by into 4, or I can say E is equals to CV square by 8. That is the energy in 1. But we need for 2, the value has divided by 4, but in energy in each, that is CV square by 8 in this and CV square by 8 in the other. So the total energy will be the sum. So CV square by 8 plus CV square by 8. So that it will become CV square by 4. So CV square by 4, it matches with option A. Is it clear, this one? If the same question was there and they asked the total energy stored by the capacitor in parallel, but in parallel what will happen? They will receive the same voltage because the voltage is same in parallel. If voltage is V, both will have voltage V. So energy stored will be half CV square and it will also be half CV square. So when you add them, so this will become CV square. So in that case, C will be the answer if they were in parallel. But when they're in series, it is 1 by 4 CV square. To work out the capacitance, the combined capacitance will become whenever two capacitors are connected in series, the total capacitance is equals to like 1 over CT is 1 over C1 plus 1 over C2. But when two capacitors are connected in parallel, what will happen to the combined capacitance of C1 and C2? So the combined capacitance will be the sum of individual. So the total capacitance will add up when they're connected in parallel. The total. Two parallel conducting plates are separated by a distance d. A potential V is applied between the plates and a charge Q is a halfway. So which of the following give the magnitude of the force? So first we can find the strength of electric field. V is equals to ED is there. Look, it's a because between the parallel plates electric field is constant. So it is irrespective. So E over D will be equal, V over D will be equals to E. And we have the formula E is equals to F over Q. So in place of E, we can write F over Q. So if we need the force, it will be VQ divided by D is equals to F. So VQ divided by D, it matches with option C. Sorry, VQ divided by D matches with option D, not C. Because D is V into Q divided by D. The current carrying wire is placed perpendicular to a magnetic field of a magnetic flux density 0.05 Tesla. The length of a wire is 10 centimeter or 0.01 meter. Sorry, 10 centimeter was there, so 0.1 because divided by 100. And the force is this. Which of the following is a current? So we have the formula. If it is perpendicular, F is equal, formula is F is equals to BIL sine theta. When it is perpendicular, theta is always 90. So it will be the strength of a magnetic field. If we need the current, so the force is 2 exponent -3. B is the strength of a magnetic field, which is 0.05. I is a current. L is a length 0.1 and then a sine 90. So we divide this 2 into 10 to the power -3 divided by 0.05 times 0.1. Sine 90 is 1, so it does not make difference. We'll get the value for I. So 0.44. So it matches with option D because it will be 0.4. So D will be the right answer. Next is which row of the table shows a quark structure of a meson and an anti-meson. Meson means when a quark, meson means it's made up of quark and anti-quark. When there's a quark and anti-quark, we call them as a meson. So C and D are totally wrong. These two can be meson, but anti-meson should be opposite. Like if it is up, it should be anti-up, and if it is down, it will be anti-down. Here, the same particle just change the orientation, so that's why it matches with A. So the particle and antiparticle, first thing it's a meson, so it should be made up of quark and antiquark, and antiparticle, opposite particles will be there. Now, The particle has a mass of 3.4 giga electron volt per c square. Which of the following gives the mass of this particle in kg? So what is the mass of this particle in kilogram or a kg? So we have the, remember one thing, like we have the formula E is equals to mc square. So the mass in giga electron volt per c square is same as energy in giga electron volt. So if the mass is given 3.4 giga electron volt per c square, how much energy this will produce? This will produce 3.4 in giga electron volt. So first what we do, we convert this energy into joules and then just divide by the speed of a light square. Because when we divide by speed of a light square, we'll get the final result. Now, so 3.4 giga. Giga, first we'll convert into electron volt. How to convert into electron volt? Giga means 10 power 9, so it will become 3 into 10 power 9. Then we convert this into joules. How we convert this into joules? Because 1 electron volt is equals to 1.6 into 10 power minus 19 joules. So we multiply. Here what we did, we multiply by 10 power 9 to convert. Here we multiply by 1.6 into 10 power minus 19. So this will become 3.4 into 10 power 9 times 1.6 into 10 power minus 19. We got the answer in joules. Now, after getting the answer in joules, E is equals to mc square is there. Like this is the answer in joules. So E is equals to mc square. Because when you use this formula, energy in joules, and substitute the speed of a light in meter per second, the mass will be in kg. So the energy was 3.4 into 10 power 9 into 1.6 into 10 power minus 19 joules divided by, because I need the mass, so divided by speed of a light square. So that will be the mass in kilograms. So it matches with option D. So D will be the right answer for this. Is it clear, this one? The next question 7. The diagram shows the track of the two particles P and Q created from original particle point X. First thing, as you don't see a track of X. So what you can conclude about the track of X, you can say X is a neutral particle. How? Because there is no track of the X. X break down into two more particles and which are following a different trajectories, like which are deflecting in the different directions. This indicate that this X was a neutral particle. So which of the following can be concluded from this? P and Q have equal and opposite momentum. They don't have opposite momentum. If they were having opposite momentum, then P should move in this direction, Q should move in other direction. Then it will have opposite momentum. The original particle has no charge. So that we can conclude that the original particle does not have a charge, because original particle, there was no path for the original particle. If there is no path for the original particle, it means it was not having charge. And when the original particle break down, it break down into two different paths. No, this is not what they are not moving in opposite direction. They are moving like this. This is not the opposite direction. Opposite direction means if one moves in this way, the other will move in other way around. That is opposite direction. This they move, they have the components x component and y components are there. Their y components are opposite, but their x components are same. Yeah, to move in opposite direction, they should be 180-degree apart. Like 180-degree motion should be there. But right now, what is happening? That it is not 180 motion, as this motion will have the two component, horizontal and vertical component. Both will have. So one of the components are in the same direction. Original particle was stationary. Why we cannot say original particle was stationary? Because if original particle was stationary, so according to conservation of momentum, the two particles must move exactly 180-degree out of angle with each other, so that the momentum will be conserved. And the magnetic field is acting into the page. Why we cannot say magnetic field is into or out of the page? The problem is we don't know the nature of these particles. You don't know which is positive and which one is negative. If we know that one of them is positive, then we can apply the left-hand rule and identify the direction of a magnetic field. But as we don't know the nature of this particle, that's why we cannot say whether it is magnetic field is in or out. The drum of a washing machine rotates at a rate of 1200 rotations per minute. What is the angular velocity? We need omega, which is radian per second. This is given revolution, 1200 revolution in per minute. First these rotations actually we convert into radian. So it will be 1200 because one revolution or one rotation is equals to 2 pi radian. So 1200 will be 1200 to 2 pi. And it is per minute. In 1 minute, how many seconds are there? 60 seconds, so divided by 60. So 1200 into 2 pi divided by 60. What's the answer for this? 40 pi radian. So 40 into 2 pi, 40 into 3.14. So it will be C approximately according to the. Next is a body of a mass M has a momentum P and the kinetic energy EK. Which of the following is the kinetic energy of a body of a mass 2M, momentum 2P? So EK is equals to P square over 2M. That's a relation between the momentum and the mass and kinetic energy. E is EK, kinetic energy is P square over 2M for particles. Let's see what is the relation between kinetic energy and momentum. They are directly proportional. Like if the momentum is double, proportional square, kinetic energy will increase by 4. So due to the change in the momentum, it increases by 4. And what is the relation here with the mass and kinetic energy? It is inverse. So kinetic energy, according to this relation, if the mass is multiplied by 2, the kinetic energy will decrease by 2. Because it's for a particle, it's like this. Usually, you have studied this kinetic energy, EK is equals to half mv square. But the formula which involve the change in momentum and the mass, then you use this relation. No, we don't consider 2. 2 is a constant thing. So we don't consider that. So what will happen to kinetic energy? It will become twice. Electron can be used to investigate the atomic radii. Which of the following is not a reason why electron can be used for such as investigation? So why we don't use electron? Because usually what happens when there's a wave particle duality, that particle can act like a wave and a wave can act like a particle. But electron diffraction is possible not for it's not for the nucleus, it's for the lattice. Like example, let's say we have a lattice is there and we pass this a beam of electrons. So that case, electron is actually acting like a wave. So when it passes through, it is spread out. This is spreading of electron when it passes through the gap. What we call that as a diffraction. But electron diffraction happens for the lattice, like when we have the ionic compound, not for the nucleus. Nucleus is so small that the wavelength of electron associated with the electron is so large, it does not show diffraction. But the wavelength associated with the electron matches with the ionic spaces between, like the space between the ions in a lattice. That's why electron diffraction is observable. So electron can be accelerated to a very high speeds. Yes, they can be accelerated, but that's not the reason. Electron can have a wavelength similar to size of atomic radii. That's totally wrong. Electrons have negative charge. So what is the effect of this? Electrons have a negative charge. As these electrons are negative charge, so they will be attracted towards the nucleus. As a result, or electrons are repelled by another electron. So that's why we don't use electron in the investigation. Electron undergo diffraction. Electron can undergo diffraction, but not in the atomic nuclei. Electron can undergo diffraction when you use a lattice, ionic compound. When let's say you have ionic compound or a lattice or a crystal, when you passes through that wavelength associated with the gap size, and it causes a maximum diffraction. That's why electrons have a negative charge. Not a reason why electron can be used for such investigation.